Okay, so this is Morgan and Paul again, and we're going to be doing a little code walkthrough to show you some of the classes and files that we used in our application, OpportunisticOwnCloud.
So the first file that we want to show is the manifest, which kind of controls everything that's going on in our application. So we say our minimum SDK is 8, and we're able to target the newest, and it runs on all versions in between, so that's good. So we need to be able to use a broadcast receiver. We need to have access to the Wi-Fi state, and we need network state as well. And then we write and read from external storage. The last thing, when you're registering a broadcast receiver, we do it in a static way, so it's in the manifest. This is basically saying we're listening for these actions or these system events to happen, and when that happens, it triggers our code, which is a broadcast receiver. You can also register dynamically in your code, but then if your application isn't visible, you're not actually going to receive the broadcast. So when you register via the manifest, you're going to receive it even when your code's not shown. Or if the device is in a person's pocket, it's still going to trigger this code. And we also register our sync service down here because that has to run in the background.
Cool. Do you want to go to the nice preferences? Yeah.
So these are our global preferences, just an XML file. We basically give all the options like user, password, server,
local directory.
And local directory. And this is modified via preference activity, which is we call a settings activity over here. And that's when the user clicks on the settings button, it just builds the standard preference activity, the view that one would expect from an Android application, and they can edit their preferences here. And those are shared application-wide via the application context. So every activity, every piece of code in our project is able to access these preferences. So the next thing to show is the receiver itself. So broadcast receivers have to be relatively simple code because they're short-lived, and if you leave the on-receive method at all, basically the broadcast receiver gets recycled by the runtime. So there's nowhere to return if you jump off and do some asynchronous code. So typically you're going to do some kind of intent and spin off a new service or tell a service to do something. So that's what we're doing here is we're causing the sync service, which is a service intent, to spin off and run once we find out that the network connectivity has changed. And here we just check whether or not we're connected via Wi-Fi. So we find out if we've got a Wi-Fi adapter, and if that Wi-Fi adapter is actually connected, then we spin off the service to run a sync.
And the lifetime of this receiver it runs throughout the entire application.
Right.
So this is kind of I think one of our main components that we'll be talking about.
And this actually will receive the system events regardless of whether or not the application has been used or is visible.
Is active.
It's still getting these system events.
Awesome.
So the sync service itself is where most of the work happens. So it's scheduled by an alarm service. So the user is able to say what frequency they want this to run, and it's also triggered by the broadcast receiver event stuff. So when it happens, it runs the sync code, which the meat of it is here. Essentially, it looks at all of the files in the local directory that has been specified. Then it connects to the server and gathers all of the remote resources and then compares the two. So it finds all of the matches between the two based on name. And then at that point, if the local file is actually a directory, then it will recursively call itself. So it's syncing all files and all directories within each other. So it happens at one directory at a time, essentially, is what's happening. But the basic of it is it compares the code, or it compares the dates between the last modified for the server and the local file. If the server is newer or has a newer copy, it's going to download. If the local file is a newer copy, it uploads. And then it runs through all this. Everything is done via separate threads in order because network operations can take a long time, and we don't want to lock up the UI when we do this. So, and also newer versions of Android are going to have errors if you try to do things on the main thread.
Yeah.
But that's the basics of the sync.
So then the bulk of the UI is taken care of in the main activity. So main activity is pretty sparse. The majority of what it does is just it sets up, if it's your first run, what it does is it kind of pulls up that view, the settings view, and the settings activity class, which allows a user to enter, username, password, server URL type settings. So that's on the first run because those need to be initialized. And then the most important part of the main activity is really setting up the local and remote file fragment tab. That's actually where the UI is handled for the user. So let's go ahead and go. So here we have the local file fragment tab. There's listeners, so the two main listeners that take place here are the I think it's on click listener and then on long click listener, so it distinguishes between those two activities. So a long click will allow a file to select. It has a dialog that comes up that allows the file to be uploaded if that is a desired option. And the regular click is what allows a user to navigate through the directory, the OwnCloud directory. So to go through files, clicking on them with a single click, and kind of going down into that tree structure. I think that's kind of all that's important there. And the remote file fragment tab is very similar. A long click provides a dialog that allows a user to download a file if they select, and a single click is what provides navigation options. So yeah, here we have our click listeners. And the main function here is the list files in terms of view. I think list file, or fill file, sorry. So what fill file does is goes through all of the resources, all of the web dev resources, and it pulls out its name, the type of file that it is, and it provides the file fragment tab with a hash map of all of the items that it sees kind of in the current directory that it's at, and then displays that in a list view to the user so that they can use the UI to navigate through those files and manage those files. So that's pretty much what's in there.
That's it.
And yeah, that's it. Those are the main classes. So we look forward to talking about them more on Wednesday. This is Morgan and Paul, and we're going to be demoing our project for CS263. We're demoing today on a Nexus S emulator, and it's running Gingerbread. And the name of our application is OpportunisticOwnCloud. So let's go. Alright, so here we are. You can see the two main tabs. There's a local files tab and a remote files tab. So the blue underscore kind of indicates what tab is active at the present moment. And we display in the Remote Files tab all of the files that are in the WebDAV server that have been indicated in the settings. So all of these files here are files that we have on our own cloud server, and those are all represented in the Remote tab. And in the Local Files tab, we're displaying files that are in the SD card OwnCloud directory. So, and this sync button here, whenever that is clicked, that automatically syncs whatever files have been updated on the local files up to the server. And if there's changes that are on the server that are more recent than what is present on the local device, then those are downloaded to SD card OwnCloud. We also have a settings button, and this allows a user to set up their username and password for the WebDAV server that they're wanting to sync with. So here we have it set up to our own cloud server. This also allows for a user to indicate the local directory that they want to sync from. And here we indicate the sync frequency. So this can occur, synchronizations can occur in the background at frequencies that the user specifies from 15 minutes to 6 hours, or you don't even need to run it as a background. And we also have this opportunistic check button. And when that has been selected, it allows files to be opportunistically synced when a network event such as Wi-Fi connectivity occurs. And Paul, I'll let you speak to that.
So the opportunistic sync is, it overrides all other settings in terms of synchronization. So even though you may have set sync frequency to 1 hour or 15 minutes or whatever you've chosen, that timed sync frequency is not going to happen if you've checked the opportunistic sync. So basically, the only time it's going to sync is when you have Wi-Fi connectivity, or when you enter Wi-Fi connectivity. At that point, it will start syncing. Alternatively, the refresh button overrides everything and causes the sync to happen on demand. But yeah, the opportunistic sync is solely focused on offloading and deferring syncing until Wi-Fi connectivity is there.
Cool. So let's go back. And why don't we demonstrate the navigation? So one of the things that these two tabs do is provide a visual interface for users to navigate through their own cloud. Sometimes with the emulator it's a little hard. You double click and you're supposed to just do a single click. Much easier on a touch screen.
So you can see the files and folders here.
Yeah, and you can go back to the root directory. And let's select something to upload. So if you long click a file, this option to upload comes up and you can select that. So upload was successful.
That was on another file. So refresh. Now if we look at
another file.
It's refreshing the server. Another file.
I don't think, well,
Oh, it actually hasn't been modified. That's the thing.
Yeah, it has not been modified, so that's not reflected in the update time. But if we were to go, well, we can modify the file on the server and then download it.
Sure. So let's show downloading first.
Okay.
So we can download a 1 megabyte file from the server.
And it's a similar long click provides the option to do these on demand. So what's cool with the on demand upload and download is that it overrides manually any synchronization settings. So if you don't want to wait, 15 minutes or 3 hours for a file to get synced up automatically, a user can override that and do that manually. So here we have our 1 meg file.
Which has been downloaded to the emulator's SD card.
Awesome.
If we want to download let's delete the folder that's
on the remote. Oh, I
yeah.
see. On the local.
So we remove the local folder, so there's no longer a directory. And this is a semi-complicated scenario since folders actually got nested folders within it, as you can see, and files. So say we're on the server side here, we're going to download the entire directory and every directory below it. And our code recursively goes through and figures out all of the files and directories that need to be built on the system. So now if we look at it on the system side, we see that we've got this directory named folder, and it's got a directory inside of it as well as a file. We go inside of that second directory. You've got another set, third directory, and another file, and so on. So we're able to download everything within that directory structure.
Awesome. Okay, and what is there? Oh, let's try modifying.
So
I think it's just echo.
Let's act as though we're going to modify a local file. Say test. We're going to append that to new file here. So that means the local version of the file is actually newer than the server version of the file. So if you look at the server version of the file, here's all of the text that's on there. It doesn't reflect this new text that we've just added. So we cause a sync event to happen. And let's go back to our files. Once syncing is complete, which shouldn't take too long because there's only one change, and we've now got test appended. So we're able to upload. It figures out, okay, this file on the local directory is newer and modified more recently than the remote directory, and so it uploaded it. So alternatively, we could, if you have a folder or a file on the server that's been modified more recently, we can, what do we have locally? Android. Oh no, let's do another file. Is that the one I was just in?
Yeah. Make it be polite.
Mo for oh you want to say that? I see what you're saying. CS 263. Okay.
Yes. Perfect.
So we save it. So this means the server file is actually fresher than the local file. So we sync again, and now we can just cat another file.
And we have successfully updated it.
You've got the update, and it shows. The last thing we would want to show is the opportunistic sync, but unfortunately with the Mac and the emulator, we're unable to trigger a Wi-Fi event. So,
but we will be demoing that on a different emulator that we'll use in the demo in class on Wednesday. And this is also, it works on actual device that we have this running on. So it's unfortunately just the emulator that we're using for this video right now. And yeah, I think that's pretty much it. In the future, we're hoping to add, especially in the local files, some more file management, well, both local and remote, such as deleting files, copying files, removing files, and moving them, I suppose, and eventually maybe even adding some sharing characteristics that would make it more OwnCloud specific. Right now, it's really just relying on the WebDAV technology to communicate files across the network. But as it becomes more integrated with OwnCloud, I think that we could probably do some sharing management on here as well, which
And I think we'll probably look to add some peer
yeah,
file
maybe
sharing.
yeah, some peer-to-peer file sharing, and unfortunately, with the some of the devices that we were using, we were unable to use NFC to do phone-to-phone sharing. But that's another thing we hope to accomplish, is to get a newer device. It's running a newer operating system, and kind of use NFC to facilitate some file sharing and synchronization. So yeah, that's all, and we look forward to demoing for you on Wednesday.